Hello everyone, Mr. Hempstead here, back with another great one, this time on density. Our target today is to be able to solve a density problem using the IFSMU method. If you have never heard of IFSMU, you are just like all of your peers. You will be learning about that in today's lesson. Stay tuned. What you need to do for today's lesson is, as I'm going through the PowerPoint slides, there will be writing that is green. Anything that is green in writing is writing that should be written into the density note guides that is posted with this assignment on our Google Classroom page. So make sure that you've got the density note guide file and are following along with that. Feel free to pause the video at any point in time so that you have time to write things down and to listen. Let's get into it. So, as I mentioned, today is all about density. And it makes sense to just start off by talking a little bit about what whoa, there we go. Okay, good. So it just makes sense to start off with a little bit of a conversation about just what density is. This is something that we briefly discussed on Wednesday of last week. Density is just simply a comparison of how much matter is in a certain amount of space. Another way of saying this is just how much stuff, how many atoms are squeezed into a certain amount of space. Um, the air in the room. There are very few atoms in the air in the room, but it takes up a lot of space. So that is an example of low density, and we know it's low density because water is like a lake, for example. A lake water typically has air on top of it. Things with low density float above things with higher density. Higher density things like a rock sink, and we know that because when we throw a rock in a lake, it sinks to the bottom. Okay. So density is just how much stuff is in a certain amount of space. Feel free to pause the video. I'm going to move on to the next slide. All right. So here is just kind of a question for you. If it helps, think about this in terms of like people in a crowd. Each of these little yellow dots represents a person in a room. Which of these rooms is more dense? Which of these rooms is less dense? Go ahead, pause the video, take some time, fill in your responses, and see if they're right. All right, let's see if you're right. So, the one on the left is less dense. There are fewer circles in the same amount of space. And so it is not quite as packed. It's not as filled as the other room is. Okay, let's try one more example problem. This time, both rooms have the same number of people, but one of the rooms is bigger. Which one is more dense? Which one is less dense? Go ahead, pause the video and see if you can figure it out. So, for this problem, the one on the left is actually more dense and the one on the right is less dense. Even though they've got the same number of people, even though they have the same amount of matter, because this is taking up less space, it's more packed together and it's more dense. Cool. All right. This is something that I just gave you verbatim because it's kind of difficult to write it in the Google Doc format. Density is a scientific concept and it is something that we can solve for mathematically. In fact, we have a very useful formula. Density equals the mass of an object divided by the volume of that object. And there are a bunch of different units that we can get for density. You guys know that whenever we use a triple beam balance, we commonly measure things in grams. Grams are a unit of mass. And volume can be measured in milliliters or cubic centimeters, depending on if we're measuring it with a graduated cylinder or if we're measuring a box with a ruler. So density, its units are just the units of mass divided by the units of volume. And there are a couple of different ways we can show that, as seen in this slide. Units are very important, and it's very easy to forget those units. So anytime that you write a number in a problem, you also need to write your units. Okay, so we've got a formula. How do we use that formula? This is effectively our target for today right here, is understanding this slide and how to use this process. This is a lot to take in, so go ahead, pause the video, read it for yourself, and then we're going to go over it. Fill in those responses in your Google form. The first step in IFSMU is to identify the things that we know and what we don't know in a problem. Do we know the mass of the object? Do we know the volume of the object? If we know those two things, we can find the density. What's our formula? For the next couple of days, our formula is going to be the same. We're going to keep the math very simple. Our formula will always be density equals mass divided by volume. But over the course of the semester, we're going to learn other formulas as well. And so it's always important to write in the formula that we're using so that we don't get it confused with other ones. The next step is to substitute what we know into the formula and solve it. Plug those numbers into a calculator, see what numbers come out. And anytime we are showing our work, we're also showing units. Anytime there is a number that we are mathematically writing out, there should also be a unit that goes with it. Cool. We're going to go over two density problems together. For these problems, if you would prefer to do them on paper, that's just fine. I recognize that the Google Classroom formatting, the Google Doc formatting can be a little weird. So if you would prefer to write what I am writing on paper and then just simply describe for me what you're writing in here, I'm fine with that. My plan is to use Desmos in the future. I just didn't really have that set up when I created all of this stuff, but we'll get to that eventually. Okay, so we're going to do one problem together, and I'm going to have you guys try one problem on your own. So, problem number one, we need to identify what we know in this problem and what we don't know. So first off, the question is asking us to find the density of the object, a paperclip. We don't know the density. It's a bit of a question mark right now. But we do know the mass. We know the object has a mass of 9 grams. Great. And we also know the volume. We know that the volume of this object is 3 cubic centimeters. I'm just going to copy and paste that. Nice. Okay. Next, we need to write our formula. Our formula will always be density equals mass divided by volume, at least for the next couple of days, while we're just getting things figured out. Then what we need to do is we need to substitute the numbers that we know into this problem. At this point, I'd like you to just pause the video for a minute and think, what do we need to plug into this equation in order to find the density? Where should the numbers go? What do you think it should look like? Okay. Let's see if you're right. So, density equals mass, which is 9 grams, divided by the volume, which is 3 cubic centimeters. Were you right? If not, that's okay. We're going to do a bunch of problems to practice with this. If you were, did you remember your units? The units are very important. Anytime you see me write a number on the board, there should be a unit accompanying it. And anytime you write a number, there should be units that accompany it, at least in science class. Okay, so next step, we need to do our math. We need to plug those numbers into our calculator, and we need to write our answer with our units. So 9 divided by 3 when we plug it into a calculator equals 3. And our units, how do we write our units for this problem? Well, we just look at our work. It's just grams divided by cubic centimeters. Ta-da! That is our answer. 3 grams per cubic centimeter. And I think one thing that's really useful is you can see how easy it was for me to figure out my units at the very end of this problem because I had my units already written in my substitution step, and I knew what units to put in there because I had my units from my identify step. when we show our units in our work, it's a lot easier for us to see where the units in our answer came from. Cool. What I would like you guys to do is to try this second problem on your own. See if you can solve it. Good luck. Bye.